Section 12.4a is about dividing rational expressions. When we have two expressions here that are being divided, typically we don't like to divide by fractions. So what we can do is take this second fraction and flip it and turn it into a multiplication problem. That's called multiplying by the reciprocal. So we're going to take this division, replace it with a multiplication sign, and then take this second fraction and flip it. And now it becomes a multiplication of rational expressions, which you've already done. So we can cancel 5 and 10, leaving a 2. Cancel the 2x squareds. Cancel a 7 and a 21, leaving a 3. Answer here then will be 3/2. So all you're really doing for these problems is turning them into multiplication and then solving them like we've done in the last couple sections. Here's one that's a little more complicated. We'll start by leaving the first fraction alone and then using the reciprocal of the second fraction, so n plus 4 over 2n plus 2. One thing you might notice is this 2n plus 2 needs to be factored. I personally think it's easier to turn it to multiplication first and then factor. So here we'll take the 2 out, leaving an n plus 1. And now you should be able to factor groups. I see an n plus 1 on the bottom, n plus 1 on the top. I don't see anything else that factors, however. So we'll have an n plus 4 on the top, and then we usually write the 2 in front of the n plus 3. And that's all that we can do to factor that one. In this next example, we're going to start by leaving the first fraction alone. So you want to imagine that this binomial is over 1, so that when you turn it to a multiplication, you can use the reciprocal. I notice the 5a plus 10 can factor by pulling a 5 out. So I'm going to do that, and now I can cancel a plus 2, a plus 2. So I'm left with a 5 on top and an a plus 5 on the bottom. Our last example, we'll leave the first fraction alone. Second fraction, we'll use the reciprocal. Now I can factor this trinomial over here. I'm going to try to do it in my head, something that you should increasingly be able to do as we practice the diamond more and more. So I need two factors of 2 that add to be 3. Sounds like a 1 and a 2. So that trinomial will factor, and now I can look for things to cancel. M plus 2 on top and bottom will cancel. So I'm left with m plus 1 squared on the top and a 4 on the bottom. You could simplify that top by distributing the two binomials and getting a perfect square trinomial, or foiling it. You can't make it x squared plus, or m squared plus 1. You can't do that. But this is also a fine answer.